This is tutorial number 1 of digital signal processing. Consider this question. Um, Consider the analog signal XAT is equal 3 sine 100 phi t. Then you are asked to sketch that signal. Then the signal is sampled with a sampling rate fs 300 samples per second. Determine the frequency of the discrete time signal xn. Xn is actually xant. Capital T is the sampling time, which is equal to 1 over fs, and you are asked to show it is periodic. Okay. Then compute the sample values of xn. Sketch xn on the same diagram with xat. What is the period of the discrete time signal in millisecond? Okay, so we'll take a look at part A. Okay, so here as you can see, I have drawn this signal xat 3 sine 100 phi t. We can write it as 3 sine 25 into 50 t. That means frequency is 50 hertz and periodic time is equal to 1 over 50, which is 20 milliseconds. So I have marked those things. So my x-axis is time, y-axis is xat. So it looks like this. Then my sampling frequency is fs, which is 300 samples per second, right? That means sampling time ts or t, that is equal to 1 over 300, which is 1 over fs. So how can we convert analog signal to discrete signal, continuous time to discrete time, right? We are sampling, therefore replace simple t with nt, n capital T. Capital T is actually the sampling time. So in here t is equal to ts, which is 1 over 300. So 3 sine 2 phi, then 50 into nts. So we are replacing only simple t value by nts, right? So therefore 3 sine 2 phi 50 divided by 300, that is actually the frequency of the signal. 50 over 300 is frequency of the signal divided by sampling frequency into n, right? Then when we simplify, it will looks like 3 sine 2 phi 1 over 6 into n. So capital F over Fs, which is simple f, that is equal to 1 over 6, and this should be a rational number. So the least value that we can get is capital N equals 6, which is called the fundamental period of the discrete time signal. Okay, so xn we can simplify further. It is 3 sine phi n over 3. Okay, and it has a fundamental period of 6 samples. So after 6 samples, it will repeat. So in here, I have drawn, I have used 2 colors, right? So the blue color that will indicate the XAT, this which is the continuous time signal or the analog signal, right? In red color, I have drawn the discrete time signal. Okay, so therefore, I have explained how to draw XAT, right? How to draw XAT, right? So we have found xn, right? Xn is equal to 3 sine. Xn is equal to 3 sine phi over 3n. Xn is equal to 3 sine phi n over 3. Xn equal 3 sine phi n over 3. So therefore, for that signal, the discrete time signal, we will substitute n equals 0. So if we substitute n equals 0, we will get it as get the value as 0. Xn will be 0 when n is equal to 0. So I have marked that point in the figure, right? Then when n is equal to 1, if the answer is equal to 3 sine phi over 3, which is 2.5981, right? Then when n is equal to 2, we will get xn as 3 sine phi 2 over 3, which is 2.5981. Then when we substitute n equal 3, we will get 3 sine phi, because 3 to 3 will cancel out, therefore the answer will be 0. Then n is equal to 4, 3 sine 4 phi over 3, that will be minus 2.5981. Okay, so likewise I can mark those, I can find those values, right? Then if I marked those y values, those xn values on the same figure where I have drawn xat, it will looks like this, right? So as you can see, uh, here it will divide, right? It will divide into a single period will be divided into 1, 2, 3, 4, 5, 6. For 6 places it will be divided, right? So when I have marked the xn value for respective simple n value, this is the figure that you are getting, right? So from this figure, if you want to get the discrete time signal, you can only consider the red color values and red color sketchings, right? So therefore here previously we have found, right? Previously we have found that the discrete time signal, it will have a period of 6. So as you can see in here, consider n equals 6, right? N equals 0, right? N equals 0 is equal to 0. Then a point which is similar to n equals 0, we are getting at n equal 6. So therefore you can see I have marked in red color the period of the discrete time signal, right? So if we consider that thing in the time domain, because we are sampling the time domain signal, the period in milliseconds, it will be 20, right? It will be 20, and between two samples, right? Between two samples, we will have 10 over 3 milliseconds gap, right? So like this we can draw xat and xn in the same figure, right? So what I have done is, so I will explain again. I have drawn xat in blue color, right? Then by substituting values for n, I have found xn values, right? Xn is 3 sine phi n over 3. So after finding those values, I have marked those values in the given figure. Then I have obtained the discrete time signal as you can see it in here. Okay, so when I can see that this thing in when I have marked those values in the figure, what I am getting is xn, right? For xn, my horizontal axis will be n values and the vertical axis will be xn, right? And as you can see it in here, for example, when n equals 0, we are getting xn equals 0, right? So when n is equal to 6, we are getting xn equal again 0. That means that is the period of the discrete time signal. In red color I have marked the period of the discrete time signal, right? And which is equal to 20 milliseconds, right? So so you can see it in here. It is same as the period of the analog time signal, but that is because for this thing, if we have chosen a different sampling time, that period may uh, may change, right? That period may change. Okay. And here take a look at between two sample values, right? Between two sample values, the time is actually 10 over 3 milliseconds, right? 10 over 3 milliseconds. So therefore here, as you can see, I have marked that one as well. So the period of the discrete time signal in milliseconds, it is equal to 20 milliseconds, right? So as an exercise, so what you can do is you can change uh, the sampling frequency, right? Sampling frequency, let's say 100, 200, um, 300 we have done, 400, 500, 600 likewise, right? Then you can try to draw these graphs, right? So what you can do is you can first draw the continuous time graph, then on top of that you can draw xn for different sampling frequencies, right? So as I have shown you, a good tool you can use it here is MATLAB. So using MATLAB, you can draw these things in a single diagram, right? So therefore, after drawing those things, you can find the period of the discrete time signal, uh, and it will change. Most probably, it will change for different sampling frequencies. Okay. Then this is the next one, right? So consider the analog signal x80. It is given as 3 cos 55t, right, plus 10 sin 305t minus cos 105t. What is the Nyquist rate of this signal, right? So if first observe the signal x80, which is the continuous time signal, right? Why we need an Nyquist rate is when we are going to sample, we need this Nyquist rate, because the sampling rate, okay, the sampling frequency should be should be twice should be uh, twice than the, at least it should be twice than the maximum frequency of the signal, right? So if we observe one by one, here 3 cos 55t, the frequency of the signal is equal to, it is 25 hertz. If we take only 3 cos 55t, frequency is equal to 25 hertz, right? Then 10 sin 305t, the frequency is equal to 150 hertz, right? 150 hertz. So if we take cos 105t, the frequency is equal to 50 hertz. So therefore, the maximum frequency that is present in x80 is, it is 150 hertz. Okay. So here maximum frequency, we can find it as 150 hertz, right? So the Nyquist rate should be 2 times maximum frequency, which is 300 hertz. So therefore, if we are choosing sampling frequency, that sampling frequency should be more than 300 hertz, right, in order to avoid or in order to omit aliasing, right? Aliasing I have explained so in the class also, right? So always the sampling frequency should be at least um, the Nyquist rate. It is better, or it should be more than the Nyquist rate in order to stop aliasing, right? So therefore the maximum, the other two frequencies we have found in here is 25 hertz and 50 hertz, right? Among 25 hertz, 50 hertz and 150 hertz, 150 hertz is the maximum frequency. Therefore Nyquist rate will be 2 times the maximum frequency, and the sampling frequency should be larger than 300 hertz. So as an example, the minimum sampling frequency we can choose in order to sample the signal is 300 hertz minimum, right? So 200 hertz, if we have chosen sampling frequency as 200 hertz, it will alias means we will not be able to reconstruct the signal if we sampled less than 300 hertz. So 400 hertz, that's better. So if we can increase the sampling frequency, that is better, but at least it should be 300 hertz. Okay. So this is the next question, right? Express the signal xn, right? So signal it is given, right? And can you see that 0 is bold here? That means that is the value at n equals 0, right? As a sum of weighted and time shifted unit samples, right? Unit sample means delta n. Unit sample means delta n, right? So weighted and time shifted unit samples means, so delta n, it can be time shifted like delta n and delta n plus n naught, delta n minus n naught, and weighted means it will be multiplied by some value, right? So first of all, we have to identify where we have uh, n equals 0, uh, n equals 0 value, right? N equals 0 value is 0, as you can see it in the figure. I have given it in bold, right? Bolded that value. So n equal 0 value is 0, right? So when n is equal to 0, uh, the the unit sample drawn at that point is delta n, right? So you can see it in the next equation. It is 0 into delta n, right? Can you see it is somewhat at the middle, okay? 0 into delta n, right? Hmm. uh, the values at the value at n equal 1 is 1, n equal 2 is 0, n equal 3 is 0, n equal 4 is 5, right? Then when we are going into the left hand side of the bolded 0, when n is equal to minus 1, again the uh, value is sample value is 0, n equal minus 2, sample value is 0, n equal minus 3, sample value is minus 2, n equal minus 4, sample value is 0, n equal minus 5, sample value is 3. So therefore likewise, when we are shifting our signal from, when we are shifting delta n, right? If we shift delta n to your left by one time, or 1, it will be delta n plus 1. So delta n plus 1 will represent there is a sample at n equal minus 1, and that value is 0, therefore 0 into delta n plus 1. Okay, so then delta n plus 2 will represent that there is a sample at n equal minus 2, and the sample value as given in the example, it is 0, therefore 0 into delta n plus 2, right? Then delta n plus 3 will say there is a sample at n equal minus 3, and that value is equal to minus 2, therefore that sample is represented by minus 2 into delta n plus 3, right? Then delta n plus 4, that will say there is a sample at n equal minus 4, and the value you can see it in here, it is 0. Therefore 0 into delta n plus 4 will represent the sample at n equal minus 4, right? Then the sample at n equal minus 5 is, the value is 3, so that is represented as 3 delta n plus 5. So delta n plus 5, say there is a sample at n equal minus 5 and that value is equal to 3. Okay, so as you can remember, when we are shifting any signal to your left hand side, it will be n plus, right? When we are shifting any signal to your right, it will be n minus, right? So then uh, delta n minus 1, that says there's a sample at n equal 1 and the value you can see it from the equation, it is 1. So therefore 1 into delta n minus 1 will represent the sample at n equal 1, right? Then 0 into delta n minus 2 will represent the sample at n equal 2. Delta n minus 3, it says there's a sample at n equal 3 and that the value of that sample is 0, right? So 0 into delta n minus 3. Then delta n minus 4 says there's a sample at n equal 4, right? So that value, and the sample value is 5, therefore 5 into delta n minus 4 will represent the sample at n equal 4. Okay, so therefore after we simplify, um, all the 0 values, they will cancel out. Therefore xn is equal to 3 delta n plus 5 minus 2 delta n plus 3, right, plus delta n minus 1 plus 5 into delta n minus 4. So according to this thing, what you can see here is there will be only samples at n equal minus 5 which has a value of 3, n equal minus 3 which has a value of minus 2, n equal 1 which has a value of 1, n equal 4 which has a value of 5. So as an exercise you can draw this thing, right? Then um, you can try to find out whether this is correct or not. Okay, so the question is given, you were given two signals, right, x1 n and x2 n, and you were asked to estimate their linear convolution, right? So I have shown you how to do this in a diagram, right? So you can try to do it in a diagram using graphs, right? So you can remember you have drawn x1k, then x2 minus k, then x2 1 minus k, likewise drawing those things, then multiplying those values, then you have estimated their linear convolution using graphs, right? So that thing you can do it in here as well, right? But in here what I will explain is the easiest method, right, which is the table method. Okay, so as you can see in here, I have bolded uh, two values in two signals, right? So those are the values at n equal 0. Okay, so x1 n, this which is equal to 1 2 3 1, the first one is the value at n equal 0, then x2 n is 4 3 2 2, 4 is the value at n equal 0, right? In order to find the linear convolution of x1 n and x2 n, right, uh, um, we have to convert their variable from n to k. So x1 k is 1 2 3 1, right? 1 is the value at k equal 0, 2 is the value at k equal 1, 3 is the value at k equal 2, 1 is the value at k equal 3, right? Then x2 k, right, 4 3 2 2, 4 is the value at k equal 4, k equal 0, 3 is the value at k equal 1, 2 is the value at k equal 2, the next 2 is the value at k equal 3, right? So therefore in the table, first of all I have written k values, right? K is the, it is the horizontal axis when we are drawing x1k and x2k, right? So k I have written from minus 3 minus 2 minus 1 0 1 2 3, right? Then below that one, so k I have isolated because that is the our horizontal axis, so our variable, right? Then x1k, right? X1k, that is 1 2 3 1, right? So as you can see, when k is equal to 0, x1k is equal to 1. When k is equal to 1, x1k is equal to 2. When k is equal to 2, x1k is 3. When k is equal to 3, x1k is equal to 1. Therefore, I have written x1k value right below the appropriate or the relevant k value, right? So we cannot change this thing because because 1 is the x1k. In x1k, 1 is the value at k equals 0, 2 is the value at k equal 1, 3 is the value at k equal 2, and 1 is the value at k equal 2, right? So therefore it should be written like this. So right below the relevant k value, the relevant x1k, it should be written. Okay, so uh, then so refer the next line, x2 minus k, right? So x2k will exist from 0 0 1 2 3, because at x2k I'm talking about x2k, it will have values like 4 3 2 2, right? 4 is the value at k equals 0, 3 is the value at k equal 1, 2 is the value at k equal 2, the next 2 is the value at k equal 3, right? So when we are finding x2 minus k, what we have to do is we have to flip the signal through the uh, vertical axis, right? So when we flip that signal, what we are getting is the can you see x2 minus k? So refer x2 minus k in there, right? In there, 4 will be the value at k equals 0, because when we are flipping it, since we are flipping it through k equal 0 line, which is the vertical axis, it will not change, right? So when x2 minus k, 4 will be at k equals 0, right? Then uh, when k is equal to minus 1, you will have 3. When k is equal to minus 2, you will have 2. When k is equal to minus 3, you will have again 2 for x2 minus k, right? So those values I have marked right below the relevant k values, right? So as you can see it in the figure, so I have written x2 minus k, right? So if you can remember, our next step is our next step should be writing or shifting this folded value to the right hand side until we are not getting an overlap, right? We are not getting until we are not getting an overlap, right? So uh, here then we are writing x2 1 minus k by shifting x2 minus k by 1 to the right hand side. So therefore it will be like 2 2 3 4 starting from k equal minus 2, right? Then x2 2 minus k, it will be shifted version of x2 1 minus k by 1 to the right hand side. So therefore it will start from k equal minus 1. Then x2 3 minus k, shift x2 2 minus k by 1. Therefore it will be starting from k equals 0. So you can see 2 2 3 0, it is starting from k equal 0, right? Then shift this thing again, we can get x2 4 minus k to your right. Okay, so it will be starting from k equal 1, right? Then x2 5 minus k, shift x2 4 minus k by 1. So it will be k at when k is equal to 2, it will be starting there 2 2 3 4, right? When then by shifting x2 5 minus k by 1, we can get x2 6 minus k. So it will be starting from k equal 3. So 2 2 3 4, right? We will not further write we will not further shift x2, right? We will not write x2 7 minus k because that will not overlap with x1k values, right? So can you remember, when we are finding the values, which we are doing is we will, so when we are finding the convolution, what we are doing is we will multiply these shifted versions of x2 with x1k, right? x1k will only exist from 0 to 3 when k value, for k equals 0, k equal 1, k equal 2, k equal 3, right? So x1k will exist from k equals 0 to k equals 3, right? So if we further shift x2 6 minus k, let's say x2 7 minus k, that will be, that will start, right? x2 7 minus k, that will start from k equal 4, right? So therefore when we multiply, it will not, because the x1k and x2 7 minus k are not overlapping, the answer will be 0. Therefore no point of further shifting x2, right? Therefore we will stop shifting this signal when we reach x2 6 minus k, right? So likewise, that is how we are writing shifted versions of x2, right? Then now we'll look at the right hand side of the table. You can see y values, right? So when we multiply x1k with x2 minus k, what we are getting is y0, because x2 minus k, it is like x2 0 minus k. 0 is the value of n. So y, we are finding the value of yn. So therefore when we multiply x1k with x2 minus k, what we are getting is y0, right? So it will only, so y0, it is equal to 4. 4 is getting by multiplying 4 and 1. 4 multiplied by 1, it is equal to 4, right? Then next value, multiplying x1k with x2 1 minus k, we can find y1, right? So x2 1 minus k, 1 will represent the value of n. Okay, so y1, in order to find y1, it is equal to 3 multiplied by 1 plus 4 multiplied by 2. So that is equal to 11. So y1 is equal to 11, right? Then y2, in order to find y2, what you have to do is you have to multiply x1k with x2 2 minus k. So 2 into 1 is 2, 2 in 3 into 2 is 6, 4 into 3 is 12, and y2 value you are getting it as 20. Okay, so x2, then next one y3 value. In order to find y3 value, we have to multiply x1k with x2 3 minus k. So 2 into 1 plus 2 into 2 plus 3 into 3 plus 4 into 1. We are getting y3 as 19. Okay, then 2 4 minus k multiplied by x1k, what you are getting is y4. So 2 into 2 plus 2 into 3 plus 3 into 1, 1, we are getting by 4, right? We are not multiplying the final 4 because no value at x1k. Therefore if we multiply, the value will be 0, so therefore no need. Okay, in order to find by 5, what you have to do is multiply x1k with x2 5 minus k, right? So 2 into 3 is 6 plus 2 into 1, we are getting 8, right? So the last 3 and 4 values, if even though we multiply, it will be 0, therefore we will ignore, right? Then the last one by 6, it is found by multiplying x1k with x2 6 minus k, 2 into 1, which is equal to 2, right? So therefore now we have found y0, y1, y2, y3, y4, y5, y6, right? So 0 in here, y0 means yn value when n equals 0, y1 is um, value of yn when n is equal to 1. So likewise I have found the values of yn, right? So as you can see, y0 is the value at 4. So if you refer the previous example also, uh, in this one also we can represent that as a weighted sum of weighted sum and time shifted version of unit sample. So therefore 4 delta n will represent yn. So yn it is equal to 4 delta n. 4 delta n will represent the value of yn when n equals 0, right? Then 11 delta n minus 1 will represent y1. Then 20 delta n minus 2 will represent y2. Likewise it will represent values up to y6. So the linear convolution of x1n and x2n, which is, it is yn, right? And it can be found as I have shown below, right? So I have done one example in the class also, right? So you can refer that one as well in here. Then try to do this in graphical format, then you will further understand what you need to do. Then the next question, right? So the same two signals are given and you are asked to estimate their endpoint circular convolution for n equal 4, right? So the previous one is the linear convolution, this one is the circular convolution. If you can remember, right, x1n circular convolution with x2n, we are getting an answer, right? If we discrete Fourier transform, if we DFT, right, not DTFT, if we DFT this that thing, it will result the multiplication of DFT of x1n and x2n, right? So that is why we are learning this circular convolution, right? Okay. So circular convolution we are performing with x1n and x2n. So first of all I have written x1n and x2n, right? So in x1n it is 1, 2, 3, 1. 1 is the value at n equals 0. x2n 4 is the value at n equals 0, right? Then refer the first table. First of all I will write x1n, right? x1n is 1, 2, 3, 1, right? So remember first one is the value at n equals 0, right? So then below x1n, I am writing x2n, but it is a circular shifted version, right? So therefore you have to do it with me, right? X2n, the first value I am writing as 4. 4 is the value at n equals 0. Therefore, right below the n equals 0 value of x1n, I am writing n equals 0 value at of x2n, which is 4. So 4, right? Then it is like surface shifting. Therefore, first one is 4 is shifted to right. Then the next value is 3, because 3 is the value at n equal 1. As you can see it in x2n, and 3 is the value at x2n of x2n when n equal 1. So therefore 3, 4. Then uh, then 2, 3, 4, right? Then 2, 2, 3, 4. It is like shifting it in a circular version, right? So then after we obtain 2, 2, 3, 4, we can write 2, 2, 3 by shifting 2, 2, 3, 4. So 4 is omitted, right? Then shift this one again, then 2, 2, 3 and 4 is omitted, and 2, 2, 3, 4 values are omitted, right? So I will explain again. 1, 2, 3, 1, that is the value of x1n, right? Then x2n value, right? x2n value, uh, x2n value when n equals 0, that is equal to 4. So I am writing it right below x1n value when n equals 0, which is 1. 1, 4 is written right below 1. Then 3, 4, so 3, 4, then 2, 3, 4, right? Refer x2n, we are adding here x2n, then 2, 2, 3, 4, right? So then after you obtain 2, 2, 3, 4, shift by 1, you can get 2, 2, 3, we will omit 4, right? Then 2, 2, we will omit 3 and 4, then 2, we will omit 2, 3 and 4. So likewise, the left hand side of the table is complete. Okay. So our next step is the multiplication, right? So in here, what we are multiplying is, we can refer the right hand side of the table. We will multiply x1n with shifted version of x2n, right? So when we multiply first one, it will be 4 into 1, right? 4 into 1, it is equal to 4. So 4 into 1, it is 4. Then 3 into 1 multiplied by 4 into 2, it is, in addition, it is 11. Then 2 into 1 multiplied by 3 into 2 multiplied by 4 into, sorry, 2 into 1 plus 3 into 2 plus 4 into 3, the addition will be 20. So here we are multiplying the shifted versions of x2n with x1n values, right? So if this, so here 2 next value 2 into 1 plus 2 into 2 plus 3 into 3 plus 4 into 1, and that will end up to 19, right? So likewise you can find 2 into 2 into 2, which is 4, then 2 into 3, which is 6, then 3 into 1, which is 3. So when we add all of them together, we are getting 30. Then 2 into 3 plus 2 into 1, it is 8. Then 2 into 1, it is 2. So likewise, we have obtained the right hand side of the table. So I will say that here what we are doing is we are multiplying x1n with the shifted versions of x2n. Shifted versions of x2n is in the right hand side below. The first line is actually x1. So we are multiplying shifted versions by each row. So we have obtained 4, 11, 20, 19, 13, 8, 10. So that is only the first part. Then refer to the second table. In second table, what I am writing is, in the first line, it is the value of n. N means simple n, right? So it is written 0, 1, 2, 3, 4, 5, 6. So remember, the first line is value of n. 0, 1, 2, 3, 4, 5, 6, value of n, right? So then below that, refer the second line, not the first line. Refer the second line. Second line, I am writing the values that I have obtained from previous 4, 11, 20, 19, 13, 8, 2. So in the order that I have obtained these values, I am writing 4, 11, 20, 19, 13, 8, 2, right? So 4 will be at n equals 0, 11 will be at n equal 1, 20 will be at n equal 2, 9 will be at n equal 3. The rest value 13 will be at n equal 4, 8 will be at n equal 5, 2 will be at n equal 6, right? Then here we were asked to find the circular convolution n equal 4, capital N equal 4. Therefore what we are doing is I will shift the middle row, the row that I have just explained, to your right by 4. So when I split by 4, the 4 value will start from 4 n equal 4. Now, but refer the first row of below n values, right? So any the 4, 11, 20, 19, 13, 8, 2, that will be shifted by 4 to your right. So therefore it will be like 4, 11, 20, 19, 13, 8 and 2. We don't need those things. Therefore we haven't written those values. Right? We won't be needing those things. Therefore I haven't written. Right? So I'm referring the first row below the n values. Right? So 4, 11, 20. Those are the only three values that I have written. We have to write 19, 13, 8 and 2 because we don't need those things. I haven't written. Okay. So then refer the third row below. Third row, that means the third row below in values, right? So again, capital N, the circular convolution, it is 4-point circular convolution. Then we are shifting the middle row 4 to your left, right? Then it looks like 4, 11, 20, 19, 13, 8, 2. So these values will be like 4 will be at n equal minus 4, 11 will be at n equal minus 3, 20 will be at n equal minus 2, 19 will be at n equal minus 1, 13 will be at n equal 0, 8 will be at n equal 1, 2 will be at n equal 2, right? So like so what we have done is we have written the middle row, right? 11, 20, 19, 13, 8, 2, 4 n equals 0, 4 n equal 1, 11 n equal 2, 20 n equal 3, 19 n equal 4, 13 n equal 5, 8 n equal 6, 2. I have shifted, I have written the first row by shifting it to your right by 4 times. Then the next row shifting it by 4 to your left hand side, right? So then it looks like this, right? You see I have marked these 4 values, right? Starting from 0, 1, 2, 3, right? Because our circular convolution is n equals 4 circular convolution, therefore we will only consider values of simple n equals 0, 1, 2, 3. Then what you have to do is you have to add, right? So when n equals 0, we have 4 and 13 as you can see. So 13 plus 4, 17, 8 plus 11, 19, 2 plus 20, 22, 19, there's nothing to add, therefore it is 19. Right? So therefore 17 will be the value at n equal 0, 19 will be the value at n equal 1, 22 will be the value at n equal 2, and again 19 will be the value at n equal 3. Right? So that thing I can represent in the weighted sum of time shifted unit sample, as you can see below. 17 delta n, that will represent n equals 0 value, which is 17. 19 delta n minus 1 will represent n equal 1 value. 22 delta n minus 2 will represent n equal 2 value. 19 delta n minus 3, that will represent n equal 3 value, right? So what you have to do is, in here, this is a method that I have given to you, and what you have to do is you can use the method that I have told you in the class, right? So if you can remember, in the last lecture I have in lecture number 7, I think I have given you that how to find circular convolution by drawing circles, right? By drawing circles. So using that one, try to find the um, circular convolution, then then check that answer with this, right? So you will get the same answer, right? But this method is somewhat easy compared to the previous one, because here we don't have to draw circles and everything. By using only 2 tables we can find it, right? But it is this method, it is important for you to understand, right? Because you can use it in anywhere, right? And it is much easier um, than the previous method that I have taught you in the class. So what you have to do next is use the method that I have taught you in the class, then find out whether you are getting the same answer.